static equilibrium equation are sufficient, okay, are sufficient to determine the unknown support reaction. However, for indeterminate structure, the static equilibrium equation are not sufficient to determine the unknown support reaction. Okay. So this is a difference between determinate and indeterminate structure. Okay. So first, when we consider about the deflection here, right? So if a determinate, you can see the elastic curve here. This is what we call elastic curve. The deflection of the beam is higher. Okay, compared to the here. It's a smaller based on if indeterminate structure. In terms of stress, high moment cause thicker member and more material needed. Okay, high moment, which is here, you have the high moment. So that's why the stress will be high. Okay, however, here is less because moment is scatter. I mean, in here, okay, the stress is higher. Okay, and then the stress is low here because it's distribute to the support. Okay, right. Okay, basically, okay, so let me stop. I want you to try. Okay, how to calculate determinacy. Okay, favorite. Okay. Okay, sorry. Okay. Okay, this one. Please calculate the determinacy from this structure. Can I give you about, okay, so ada 7, so you need to solve within 7 minutes. I will point a name one by one, right? using the equation for truss beam. Okay, have you done? Have you done? Have you done? Okay, I will ask. Oh, Muhammad Hakim. Figure 1. What is the classification?
It is statically indeterminate.
Okay, statically indeterminate. Okay, so berapa dia punya reaction. Your R.
There are 7 reactions.
So you have D equal to R minus N minus C. So you have 7. Okay, how to determine 7? So because this is 3, 3, 1. Okay. So minus, okay, and always using 3. Okay, because kita selalunya kita analyze the 2D structure. Okay. Right? So there is no C and it will have a 4. Okay. Siapa yang panggil? Lupa pula. Hakim.
Yes, doctor.
Atira. Figure number 2.
Yes, madam.
Figure number 2.
Saya tak buat lagi tak?
Tak buat lagi?
Oh.
Why you tak buat lagi? I bagi daripada tadi. Kenapa tak buat lagi? You just waiting the answer. That's it. Okay, kalau I kata buat, then I will ask. So, it's compulsory. No waiting. If you don't want to tak jawab, so I know your capability. Okay, so I don't know, I tak tahu nanti macam mana. You can, you nak buat. Right, so Afrina. Nur Afrina Batrisha. Afrina Batrisha? Tak ada? Tak datang? Where's Afrina? Afrina Batrisha, I can see your name. Afrina, please anticipate with the class, okay? If you don't want to anticipate, you can left my online class. Sebab tu I tak suka online ni. Bila I panggil, I rasa macam I panggil seorang-seorang. Okay, please anticipate. You rasa macam it's just online. Kalau you tak ada kamera, I can okay, but if I'm asking, please respond. Okay, me. Right. Haziq. Muhammad Haziq. Number 2.
Ya saya
Okay.
dapat Dida dapat 3.
Okay, D dapat 3. Okay, good. So how you determine the reaction? How many reaction that you have?
6.
6. Good. So is so it adalah indeterminate.
Indeterminate.
Right? So bila lebih daripada kosong, maksud dia indeterminate. Bila dia sama dengan kosong, dia adalah determinate. Okay, figure 3. One Nur Amira.
Yes, madam.
Alright, so the figure 3, you dapat berapa?
I got 1.
Dapat 1. Good. So dia indeterminate. Okay, so you akan tahu dekat pin ada 2 and then the other roller is 1. And then you have hinge here. Okay, so ada hinge di sini. Right, so dapat 1. Right, so now figure 4. Ronaldo.
Yes, madam.
Alright, so figure 4. How many? You dapat berapa?
Is it this the statistically determinate
Okay,
structure?
yes. So determinate
Uh,
structure.
I have the reaction is 5,
Okay, so you ada R5, okay?
and then for the n is 3,
Okay, and always 3. And
and
then
then
the
for
hinge,
the hinge is it
number
1,
2.
2?
How many? 1. This is a 1, 2. So sebab tu you dapat
Yeah, 0.
H. Right? Okay.
Okay.
So figure 5. Alia. Alia Najiha. Okay. So you dapat 2. So reaction ada berapa?
Reaction ada 6.
6, betul? Because it's a fix. And then and always 3, right? Okay, so and then you dapat 1. Okay, so you akan dapat 2. D itu 2. Figure 6. Dayang.
2.
You dapat 2. Macam mana you kira 2? You pakai equation apa?
Plain truss.
Okay, plain truss, which is M.
Plus R minus NJ.
MJ or 2J je lah. So which is plain truss is 2. Okay. M tu 2. Kalau plain truss. So M is a member. How many member that you have?
16.
16. Macam mana you kira 16 eh? So this is a 1, 2, 3,
3. Yes.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It's a 19 member.
Oh.
So you dapat 16 tu. You tolak yang mana? You tak kira. You kira sekali ni eh. You nampak tak ni join?
Yeah.
Okay. It's a 19. Okay. So N R reaction berapa?
Reaction 3.
Okay, 3. Right? Okay, so you minus 2. The join. So bila ada ni, you akan kira ikut join. Okay, berapa join dia? Berapa join dia? Kira.
6.
6. So betul lah. 6.
7. 7.
7.
1, 2, 3. 3, 6, 7, 8, 9. 9.
9.
9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Confirm.
Confirm.
No, 11. It's 11.
Oh, including the reaction, the support.
Yes, it's a join between member and the support. How come? Okay. So, it's 11. So, you dapat dia adalah determinate. Okay? Alright, thank you. Apa tadi? Lupa nama dia. Auni eh? Okay, the last one, figure 7. Mio Amirul Aiman. Where is Mio? Tak ada, tak datang. I tak dengar suara. I tak dengar suara, Mio. So lepas ni make sure dalam 3 minggu ni you carilah mic tu, try before my class. So I will pick one by one, so be prepared. So kalau you rasa tak suka, terpulang kat you. This is how my class, I will push you beyond your capability. Okay? So tak boleh? Tak dengar, tak dengar. So tak apa. You try je kat sini. At least you respond me. Okay. Mio, you dapat apa? Lepas ni, cuba cari. Cuba test. Sebenarnya you kena test your microphone. 0? Yes, correct. Okay. So it's determinate. So determinate. Alright. So you dapat 0, betul. So, you akan ada berapa member? 9. 9. Betul? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus reaction is 3. Okay, ni pin, ni roller, ni pin. Minus 2 join. 1, 2, 3, 4, 5, 6. So 0. Okay? Alright, good. So that's why I memang akan bertanya macam ni setiap kelas. Okay, and then I akan bagi soalan-soalan yang memang memerlukan instant answer. Okay, so let's continue. Okay, I kena continue balik. Yang tadi, where is this one? Okay. Okay. Okay, can you see? Okay, so continue. Okay, so since this is a kinematic, sorry. Sepertinya kat sini, okay. Kinematic indeterminacy. Okay, so we more focus on indeterminacy because determinate, statically determinacy or statically determinate, dia cuma kira melalui what we call equation of equilibrium. Okay, so kinematic indeterminacy, in the stiffness method, the displacement of the joint become the unknown quantities. Okay, so basically you have been learned in term force method, stiffness method, and moment distribution method. Okay, so stiffness method, we find a displacement. Okay, all right, so this we call kinematic indeterminacy. Right? So that's why kinematic indeterminacy more to displacement. Okay. When the load are applied on the structure, each joint will be undergo displacement. Okay, translation and rotation. So I will explain more into the when we go for stiffness method. Okay, some displacement may be known, others unknown. The number of unknown joint displacement is the degree of kinematic indeterminacy or number of degree of freedom. Okay, for kinematic indeterminacy, more to degree of freedom. Okay, right, this is a sum of idealized structure, so you need to know, right? So we need to idealize a structure so that structure engineer can perform practical force analysis of the member. So bila you portray the real structure to idealized structure, which yang you lukis idealized. So this is what we can see. Okay, point support. Okay, and then a pin connected joint. Okay, this is a pin connected. Okay, we have a frame. Frame dia adalah pin connected. Okay, even truss you have a pin connected kat situ. Okay, oh sorry, truss. Okay, torsional spring support. Okay, because they have a K spring element. Torsional spring joint, you have a K. When we talk about spring, there are the K. K means the spring or okay. K stiffness spring macam tu. Fixed support, fixed jointed connected joint. So you akan nampak dia lebih kurang macam ni lah kan. Okay. Okay, so pin connection allows some freedom for slight rotation. It's the same as a roller support, allows some freedom for slight rotation. However, fixed joint allows no relative rotation. Okay, so dia tak allow rotation tu. Okay, this is some of the support connection. Okay, I have given to you, right? Okay, so this is some of kinematic indeterminacy example. Okay, if joint B, okay, joint B has 2 degree of freedom, rotation and translation. Okay, I nak lukis sebenarnya susah sikit. Okay, rotation mean moment. Okay, bukan tak boleh sebab I pakai yang ni. I tak share with. Okay, okay, I rasa boleh ni. Okay, okay. So you have joint B 2 degree. So because you have rotation and translation. Okay, rotation. Okay, and then translation. Okay, translation ni dia ada X and Y tau. Okay, right. It's a normal to neglect axial deformation and thus no translation. So joint B has only 1 degree of freedom, which is rotation. So means that we eliminate this part. Okay, so dia ada satu saja. Now in the detail kita akan belajar masa stiffness method. Okay, so here 7 degree of freedom if including axial deformation, 4 degree of freedom if no axial. Okay, 7 degree of freedom. Okay, ni joint B 7 degree of freedom you kena tengok dekat joint. Okay, so dia ada satu, sini ada satu, 2, 3, ni ada 4 lah. Ni 6, masuk axial. Okay, kalau kita ignore lah. So dia jadi 4. Tak ada. Okay. Stop. Tak boleh pergi next eh? Stop. Okay. Alright, so here kinematic determinate the 0 degree of freedom. Okay, so determinate. Okay, so for here joint A, B, C and D each has 2 degree of freedom. Joint A, B, C 2 degree of freedom sebab dia pin jointed. So dia ada X and Y, X and Y, X and Y. Okay. EF has 0 and 1 degree of freedom respectively. So E and F. So dia ada 1, 0 and then dia adalah 1. Okay. For F. Thus kinematic indeterminate to the 9 degree. So kalau campur tu dia jadi 9 degree. Okay, tak apa. Alright, so in here summary analysis of indeterminate, which is what we have a flexibility moment is degree of static indeterminacy, so kita akan kira redundant. Okay, kinetic indeterminacy kita akan kira degree of freedom. Okay, degree of freedom. Okay, kalau kita tengok flexibility method ni, degree of static indeterminacy redundant means that at support. Okay, for stiffness method, kinematic indeterminacy. Okay, kinematic means that the displacement. Okay, kita kira displacement dulu, degree of freedom. Displacement, it come from translation and rotation. Means translation tu displacement lah. And then rotation tu caused by moment. All right. So, it's done. All right. I give you 5 minutes break before we proceed with the next part of the structure system using a virtual world. Fine, we start 11, 12, 12:03, okay? Okay, let me start our structural system, which is determinate. Okay, so the topic 1, okay, chapter 1, we cover for determinate as I mentioned yesterday. All right, so the topic 1, basically, we want to identify the deflection of the structure, okay, based by using direct equilibrium equation. But here, we can identify the deflection by using a visual work. How it's, okay, how we want to use the visual work. Okay, so for here, the topic 1, chapter 1, we focus on the truss, beam and frame. Okay, actually the equation is the same for beam and frames, and that is a composite structure. Okay, so first we identify the determinacy. Okay, you identify the determinacy. Okay, kira lah 1, 2, 3, 4, 5 member and then reaction 1, 2, 3. Okay, so this is what we call a real structure because this is a real structure with the load applied. Aisyah, diam sikit. Diam sikit. Okay, alright. So due to point load here, okay, you nampak is a horizontally applied load P. Okay, dia tarik kan. Right? So therefore, there will be a deflection due to horizontal. Okay, and then why at the support roller dia bergerak? Sebab dia roller in the horizontal, dia of course dia bergerak dekat horizontal. However, for pin, dia tak bergerak X dengan Y. So that what we call deformed state. Okay, so maksud dia bila you tarik, dia akan bergerak. So bila dia bergerak, then it what we call displacement or deflection. So it's deflects the structure. Okay, so kita akan nampak kat situ. Okay, that's why we call visual structure. Okay, visual structure. So you need to visualize apa jadi dekat structure tersebut. Okay. Alright. So how we want to use the visual structure? Okay, or visual work. So external work equal to internal work. How? The external work, okay, terjadinya external work melalui load P. Okay, then we times with the displacement. Okay, so this is a load P for visual. So this is a visual work. When we talk about visual, so kita tengok dekat visual ni lah. Okay, alright. So equal to summation N D, which is N the member internal times with D is elongation. So N tu each member punya load. Okay, tu setiap member ni dia akan satu-satu ada elongation. So dia akan ada, you faham konsep stress and strain. Okay, masa solid tu belajar. But tu belajar solid tu is fundamental for analysis. So this is application when you learn from fundamental. Okay, by Hughes law, we know that stress equal to E strain. Okay, E is Young modulus. Strain, okay, strain and stress. Stress equal to P over A, okay, P over A or N over A. N is the axial load, okay, divided by the area. And then for strain is delta divided by length, okay, which is the elongation. What we call elongation is a deflection or displacement. Okay, dia berubah. Elongation or shortening means perubahan. Okay, divided by the original of the length. So by the substitution of this equation to the equation number 1, which is a previous equation. So therefore, okay, so this equation kita guna based on here. So because I know we want to identify the displacement. Okay, the changing of the structure. So when we talk about the changing, means that elongation, displacement, deflection. So itu yang kita nak cari. The objective for this topic. Okay, for this chapter. Alright, so you substitute. Kalau you this one you have been learned in solid. Okay, solid pun ada belajar. PL over AE to find, to identify the load, okay, the elongation, the deflection due to axial load. So that's why truss is what we call axial member, okay, axial structure. Okay, dia bukannya moment, dia tak boleh ada rotation. Okay, alright. So P here is a virtual load is equal to 1. Okay, virtual load can be due to translation. Sorry. And rotation. Okay, translation means the deflection lah, due to rotation. So kalau deformation or deflection, dia selalunya terjadi disebabkan force. Okay, force. Okay, this one disebabkan moment. So 1 unit load, it can be 1 kilonewton or 1 kilonewton meter. Okay, sebab displacement, okay, rotation is a part of displacement or deflection, deflection, okay. Okay, so you substitute 1. So therefore, general engineer for any deflection of any trade is 1 times delta equal to summation NNL divided by AE. What is NNL divided by AE? Okay, N is a for real. Okay, N is a real structure. So N means you need to find the internal member for real. Capital N. Okay, small n is for virtual, right? So L is length of member and AE is axial rigidity. Okay. If faham? Okay. We recaps to identify the reaction, okay, and also to find the internal force, okay, due to real structure. Okay, so what we call here, this is what we call real. Okay, we not remove any forces, external forces. Okay, so I want you buktikan, okay, prove me you will get this reaction. Give you time 3 minutes to answer this question. Proof. Okay. Did you get proof? Dapat?
Dapat, Doktor.
Alright, good. So, sebab I don't want you take a lot of time to calculate the reaction. Because dia bila you terlalu lama mencari reaction tersebut, dia akan jadi nanti dia akan drag the time. So you nak find the internal force. Internal force kalau banyak member, dia akan makan masa yang lama. Okay, alright. So, alright. So taking moment, so you want to, first we start with taking moment at A kan. Okay, so bila you taking moment dekat A, okay, sign ni, I tak kisah it's up to you, your decision, okay, your assumption for the sign convention here. Okay, I selalunya kalau practically, not practically, for me, I'm always using counterclockwise equal to 0. Okay, kalau you nampak nanti kat kelas next class, memang I always using summation moment equal to counterclockwise equal to 0. Okay, alright, compare, this is a positive sign for me. Okay, kalau you nak buat clockwise pun boleh. Alright, at the end, you will get the same answer. Dia jarang dia berbeza. Okay, because I'm counterclockwise is a positive. So whatever it is a counterclockwise is positive. Kalau you assume clockwise, so clockwise lah positive. Okay. Alright, so you akan, alright, so taking moment at A, so you akan dapat RC times 3, okay, minus 20 times 3 plus 10 times 4 equal to 0. So you dapat RC, so you pakai lagi satu equation, Fx, Fy, Ra plus RC. So you dapatlah nilai tersebut. Okay, alright, so HA is tahu 10. Right? So that is how we calculate reaction. And then find internal force. Okay. Use a method of joint or method of section. Okay. So I'm using the method of joint. Okay. But I'm including the ratio of the joint. Okay. And using equilibrium of the joint. Actually dia sama. Tapi student selalunya cakap dia easy method. Okay, sebenarnya dia method of joint. Rather than you writing summation force equal to 0 blah 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 times and times. So basically ia adalah yang ringkas I boleh buat. Okay. So I don't know if you have been learned back to diploma. Okay. But I'm not sure your lecturer teach you for this particular method of joint, okay? But I will use this part as my lecture, okay? Why? It's a consider as a short timing. You can save the time by using method of joint. Okay, you using the method of joint. Sama, ini pun method of joint. Tapi you can short it time. Okay, rather than you buat method of joint. Okay, you buat method of joint. I know, the previous you akan buat method of joint. Okay, you ada reaction kat sini. Dia ada 1, 2, 3, let's say. So, you akan resolvekan dia X, Y. X, ni tak adalah. Sorry. So, the X, Y. So nanti buat summation force Y equal to 0, summation F X equal to 0. So you write equation and so on, and then you simultaneously, and then you solve the problem. Okay, it's the same what I will do, but there is some of joint that we can simplify and make it an easy without writing the equation. Okay, all right. So if in here, if you look the structure, okay, all right, at bottom part here, okay, macam mana kita nak dapatkan 16.67 dengan negative 16.67 and negative 6.67. Okay, how? Okay, with the method of, my question is, how do we start? Which join that you will start first? Which join?
Join C.
Join C, okay? Yes, you can start with the join C, or okay, betul. Kalau I memang akan start dekat join C, is more easy. Okay, so dekat B pun kita dah tahu dah. Dekat B, for join B, I know that this is 0 and this is 0 because there is no load transfer from the join B. Okay, but it's not all. Okay, not all you can easily assume that is 0. Bukan, tak semuanya. Alright, okay. So, what you can do, okay, kalau you tak tahu ni kosong, tak apa, boleh. Tak apa, boleh. We start with the join C. Okay, my cara, okay, method of join. Alright, so you know that 6.67. Okay, and then you have a two join. Okay, two member join, which is a BD, a CD, and CA. Okay, so what I want to do, I know that the force acting in vertical, okay, vertical in Y direction. So selalunya kalau you method of join, you akan gunakan direction keluar daripada join tersebut. Okay, so you assume is tension, always assume as a tension, kan? Kalau you belajar, kalau belajar cara method of join, this one. Okay, so for me, cara I, okay, sebenarnya you kena practice kalau cara ni. I tak tahu you pernah buat ke tak? Pernah belajar ke tak?
Pernah, doktor?
Pernah, okay. So some of you knows, another others? Lain? Semua belajar? Please respond.
Tak pernah.
Tak pernah. So you belajar yang biasa punya je method of join, right? You kena assume as a tension, betul? All remember?
Betul.
Okay, tak apa. So kat sini apa yang I ajar, you kena practice. Kalau you tak practice, memang you tak boleh buat. Okay? Alright. So you're going up with the Y direction. So I know that this is like my bar. Okay, not bar. I can say that dia adalah center. Okay, center. So bila you see ke atas, okay, you know that when it called static, must be equal to 0. Must be equal to 0. So 6.67 in Y direction means that CD is 6.67 in going down. Okay, so dia akan dapat dekat CD 6.67. Okay, I tahu ini agak senang, mudah. So you direct macam tu je. Or you can use the same method of join. Memang you akan buat macam ni. You akan assume kalau method of join biasa, you akan assume macam ni. So you akan tulis FY to 0. And then you akan buat 6.67 plus FCD equal to 0. So you akan dapat FCD negative 6.67. Okay? Basically, dia adalah sama negative 6.67. Sebab dia ke bawah. And that is a compression because dia ke join. It's a compression. Okay? Faham? Ni baru nampak satu. Faham? Okay, CA ni. Dekat si A, dia kosong sebab there is no loading in the X direction. Sebab tu dia kosong. Okay, so that is a number join C, and then which join that you want to start? Next. Okay, you can start at D join or A join. Okay, so I will choose a D join. Okay, I choose D join. Right, so I dah tahu dekat sini 6.67 sebab dia compress. Compression. Okay, right, so dia you akan nampak dia opposite dekat bawah untuk join ni, this is join D. Okay, right. So then I have another member and another member. So I have a 20 kilonewton and then I have horizontal 10 kilonewton. Okay. So you cannot simplify that a member, this is a BD. FDB, FDA. Okay. So I tahu you akan buat nanti, kalau method of join you akan pakai summation force equal to summation force X, summation force Y. I tahu you akan lukis. Okay. So, but kalau macam ni I just buat, this is going up sebab I tahu 20.667 untuk samakan dia adalah mesti dia positif. Okay, sebab this must be equal to 0. So 20 minus 6.67 or 6.67 minus 20. So you still dapat berapa? Negatif kan? Right? Alright. So dia nak tolong untuk support 20 ni. Okay? Alright. So you akan dapat 13 point berapa? You dapat 13.33. So you dapat 13.33. Okay, why? 20 minus 6. Okay, so you dapat 13. Okay, so kalau you total up, dapat kosong. Untuk Y direction. Untuk X direction. Okay, so you tahu dekat FBD ni tak tahu lagi ni lain. Let's say you tak buat B ni lagi. You tak buat yang B ni lagi. Okay, you start dengan C and then D. You tak go jump to the B. Okay, so kat sini dekat FBD, we don't know the value. So you akan ada dua unknown, which is satu di sini, satu dekat BD ni. Ada dua. Okay, macam mana? Okay. So, if you look here, okay, kalau you nampak, you can use the ratio. Okay. So kat sini 13.33. Okay, so is untuk keratas adalah 13.33. Okay, ke sini you tak tahu which is X. So YU adalah 4. XU adalah 3. Okay. So dia ibarat trigonometri. Kalau you kecilkan pun dia ibarat trigonometri. Sama je. You just ratio. Okay. So dari sini, okay. Okay, I bawa kat sini sekejap So, you akan dapat sini adalah 13.33. Okay, sorry. Dan sini, you tak tahu X. Tapi, sini adalah sama dengan 4. Sama dengan 3. So using a ratio, let's say you pakai 13. Allah. So 13.33 divide by, okay. So dia sama dengan y over x is x, 4/3. Okay, faham tak yang ni? Faham tak? Tak faham bagi tahu. Faham? Faham tak? Okay, kalau you kira x, so you dapat berapa? X ni. Dia bukan x. X ikut tu berapa? Kalau ikut ratio ni.
9.99 equal to 10.
Okay, so you akan 9.99 kan? It's approximate 10. So, you tahu kat sini 10. So, bila 10, tolak 10, kosong kat sini. Ini cara yang paling senang lah. Not paling senang, ini method of join also. Tapi is simple and rather than you buat method of join, summation summation force x equal to f c d cos theta and so on, so on, so on. But it's just only a few join yang you boleh gunakan cara macam ni. Ada you memang akan gunakan cara method of join. This is only once or 2 join. Let's say kalau you ada 10 join, takkanlah you nak gunakan method of join yang tulis yang banyak-banyak tu. If I said, kalau you tulis banyak-banyak tu, markah dia hanya 10 je. Why? We not identify, if we not count it because you have been learned, basically that part is in static. Okay, static you belajar ni sebenarnya. To find the internal force for the real structure. Okay, but in here, what I want you try by using the simple method. Okay, kalau you tanya, boleh ke buat macam ni, dapat ke markah? Yes, you can get the marks because 1 mark is just represent the internal member, bukannya cara pengiraan you. Markah tu dia beri berdasarkan answer you. Okay, member tu. Tapi, because in the table, you kena perlukan N saja, bukan cara macam mana tu. So, kalau you tak nak tulis and then directly in the real structure you buat macam ni, tak perlu ada equation and so on, boleh. We accept. Okay, right? Faham? So, this part you need to practice and practice and practice. Siapa yang tak tahu, okay, siapa yang tak biasa, you need to practice. If you not practice, memang you tak boleh buat. Percayalah. My class, first time memang previous class, first time bila dia buat, dia memang tak boleh. And then, I give a question and then you try. And Alhamdulillah, then at the test or final exam, dia orang buat cara macam ni. So, it's save time. Rather than yang buat internal forces yang biasa-biasa tu, bukan I kata tak boleh. Okay. You try this one and you try the method of join yang biasa and you compare time, you solve the problem. Okay, kalau you dah biasa. Okay, alright. If this method or method of join, this part, rasa lagi mudah, try it. But I tak kata you kena ikut I. No. If you convenient to use the method of join seperti biasa, it's up to you. Okay, I'm trying to adding another way how to solve easily the trust. Okay, alright. So is it clear? Boleh?
Boleh, Doktor.
Boleh, Doktor.
Okay. So next, okay, this is what we going to learn about visual work. Okay, yang tadi tu sebenarnya adalah recap pun, perkataan pun dah recap, tapi I still teaching you the way I'm find the internal force. Okay, so this is what we want to identify by using visual work. Okay, so you need to divide by you have a two structure. Okay, one structure is a real and then another one is a virtual. So the real structure is the all in here. But when we come to the virtual load, okay, virtual structure, you need to ignore the real load and apply virtual load. Okay, 1 unit load. Okay, since our objective to find deflection means that we apply 1 kilonewton. Okay, all right. So they say that it's stated that vertically. When it's stated as vertically, so means that 1 kilonewton vertically. Okay, bukannya horizontal. Kalau dia tanya dekat horizontal, you kena apply lah kat horizontal. Kalau dia tanya find deflection at D, means kita akan ada dua. Deflection, horizontal and vertical. So you akan ada dua. So ada dua means that you will have two virtual structure. You tak boleh letak 1 kilonewton di sini. No. You tak boleh. No. No, you tak boleh ada dua 1 kilonewton. As I said, 1 unit load. A unit load. Okay, kalau a unit load, dia ada satu je. Dia tak ada dua, tak ada tiga, tak ada empat, tak ada lima dan so on. Okay, faham? Kalau dia tanya deflection dekat D. And then, beam, thrust tak ada rotation. Kalau dekat beam, let's say dia tanya rotation and deflection. So, you akan ada satu untuk rotation, satu untuk deflection. So, dah ada dua. Okay. I believe masa diploma you belajar deflection. Okay. Yang solid mechanic, integration method and so on. So, sama juga bila you cari deflection untuk beam. Kalau deflection, you ada satu equation. Untuk rotation, you ada satu equation. So, maksud dia macam tu. So, maknanya virtual work, kalau untuk vertical dia ada satu, untuk horizontal ada satu. Dia tak boleh combine. It's what we call a unit load. Okay. Okay. So how we solve? Okay, kalau kita check kat sini, how we solve? Kita share, solve by superposition. Okay, ni adalah nama dia superposition lah. Okay, sama je. Okay, so we need to find N in the real. N, as I say, is internal forces of real structure. Capital N. Small n is internal forces of virtual structure. So you cari lah. So when we apply 1 kilonewton here, so you cari macam biasa, stage dia sama je satu, you akan cari reaction at support. Okay, dua internal force. Okay, so bila dapat satu dan dua ni, internal force sama lah bila you dapat reaction ni. So sini kosong, Y you start with the C. So dapatlah -1. Okay, clear? Faham tak yang ni? Boleh? Boleh?
Saya nak tanya,
Okay.
untuk yang virtual force tu memang dia fix 1 kilonewton ke?
I dah cakap tadi. It's a unit load. So a unit load
Oh.
maksud dia apa? Satu saja.
Satu je.
Oh. Dia
Okey,
tak boleh
thank you
letak
doktor.
2, 3, 4, 5, 6, 7, 8. Dia memang satu. Dekat structure tu dia ada satu je. Is it the vertical or horizontal or rotation? Dia tiga lah maksud dia. Tapi dia depend pada, sebab I cakap or bukan and. You kena faham? In the virtual structure, it can be vertical or horizontal or rotation. So rotation 1 kilonewton meter, vertical and horizontal 1 kilonewton. So kalau dia suruh cari semua, so maksudnya you ada 3 virtual structure. So you ada N1, N2, N3. Okay? Dia tak boleh campur. Alright. Okay. So then you need to make it a table. So senang sikit nak buat table. Buat table lah. Okay. Okay. So based on the equation yang kita dapat tadi, okay. Delta vertical and, okay, you cari, letaklah semua yang you dah cari tu. Masukkan dalam table. Real moment. Okay, real force. Okay, real internal force, and capital N, and then small n is internal force for visual member. Okay, so member you length you cari sendiri, semua length kena cari. Sini 4, this is 4, this is 4, this is 3, this is of 3. Then how become this one? 3, 4, 5. Okay, so hypotenuse. So triangular. So kena tahulah 3, 4, 5. Apa lagi semua. Kalau tak, bukan 3, 4, 5. Is already given angle, macam mana nak cari length tu. So that's one is a basic mathematics. Okay, so masukkan. So masukkan nilai-nilai tersebut. So you darabkan siap-siap. Okay, so you total up and then you get the 26.68. So you dapat 28.68. Then you substitute into the equation, you dapat 28 divided by 500, which is your AE. And then you will get 0.05336 meter. Okay, this one is dalam meter. Kecuali you letaklah kilonewton kat bawah ni. Kuasa kuat 3 ni. So dia dapat terus mm. Okay, 500 kilonewton dalam soalan. So dia dapat 53.36 mm. So what happened? Dia adalah jatuh ke bawah. Okay, vertical sebanyak 53.36. So actually you boleh, okay, nanti you akan try. Okay, I want you to try. Okay, try dapatkan delta di horizontal. Okay, you cuma kalau delta horizontal ni cuma cari visual je. You tak perlu cari real. Real sama. Benda yang sama. You cari visual saja. Okay, nanti I want you try this one. Okay, buat. Okay, so because last class until here saja. So I dah bagi nota. Nombor 1, nombor 2 ni dah ada. Okay, number 3 there is no solution. Nombor 1, nombor 2 tu nanti I terangkan balik. You boleh fahamkan lagi untuk kira internal forces and so on. Okay, you need to do number 3. Okay, this is one to find horizontal and vertical. So you kena buat satu-satu. Okay, so ada virtual work, dia ada 2. Okay, tapi buat real ada 1 je. Visual work dekat D, visual work dekat C. Load dia 1 kilonewton. Okay, number 3. And then I give you another 2 question. Okay, so you have a 3 question. I selalu akan bagi. So siapkan dalam masa seminggu ni. Monday I akan. Okay, let me share. Monday I akan ni PowerPoint pula, sorry. Okay, so that is a 1 question. This is a second question. Okay, this is second question. So kita, okay, find at deflection at B. Yang bawah, dia vertical kan gambar tu. So ni ada 1. Tadi 1. Ni the second one. Please take a picture. Okay, dapatkan. Right. And then dah. Then the next one is here. Oh, bukan. Mana yang hilang? Okay, this one. Another one. Okay, so you have a 3 question. So untuk question yang this one, find at C. Tengok C clear buat apa. Okay, for this question, alright, you need to find the deflection at C vertically. Okay, you kena cari vertical at C. And then EA dia 500 kilonewton. Okay, for this question. For this question EA dia sama juga pakai 500. Both EA is 500. Okay? Boleh? So you have 3 question, okay, exercise, right? And then you need to finish it before my class next week, okay, on a Monday. So siapa tak buat, I akan panggil seorang-seorang tau untuk dapatkan jawapan. Okay, jangan pas-pas you punya soalan. Jangan jadi baik, that's it. Jangan jadi baik dengan kawan you just share apa you punya jawapan. No. It's not time you nak berbuat baik waktu macam ni. Kalau exercise, buat sendiri. Jangan bila dia tak buat, you bagi je sebab nak selamatkan kawan you. Right? I tak nak macam tu. Okay, memanglah kawan, bukan maksud kawan makan kawan. Maksudnya sekarang ni, I nak you buat. I force you to do. Kalau you rasa you nak dapat A, you buatlah. Kalau you rasa nak tak buat, okay, jumpa next semester. That's it. Nampak macam harsh, tapi itulah kenyataannya. I'm gone through a lot of class. Okay, I dah ajar lama dah. Kalau you rasa you nak dapat, you akan usaha untuk dapatkan. Kalau you minat seseorang tu, you try your best untuk dapatkan. Kalau you minat sesuatu tu, you try your best, you dah dapatkan. You nak beli sesuatu, you tak cukup duit, you try your best untuk saving kan? Samalah, konsep dia sama. Okay, usaha tangga kejayaan. Dah ada banyak pepatah. Okay, alright. So any question? Any question? So far? Okay, any questions so far? I believe everyone is calm to my class. Tapi lepas ni kalau boleh ada weekend carilah, try lah microphone you ya. I memang, that's why I against with the online sebenarnya. You sometimes it's not this class sebab I nampak participant is okay, but you tend to the other class I have a complaint from other lecturer. For first class you dah minta izin yang tak munasabah, which is you pergi ambil driving school punya lah, apa lesen lah apa. Waktu cuti semester tak buat ke? Waktu yang memang critical and then you tahu boleh buat online and then you take advantage. No. It's the same as you not entering the class. Sebab itu benda yang you boleh plan hari lain. Okay, jangan. So benda kalau boleh you tak datang dengan munasabah. I tak suka benda-benda yang tak munasabah ni. Okay, kalau you pergi, kalau you sakit, it should be okay lah. Kalau you dah memang sakit, demam, you kena pergi doktor, you kena jumpa doktor, yes. It's okay, that is beyond our control. Tapi yang benda you boleh control, which is macam you nak jumpa, you nak ambil driving license, that's all you can control it. You boleh control benda tu. Okay? Right? Okay? Sebab you jumpa dia punya license, cikgu yang mengajar you tu, dia bukannya ikut dia, ikut you, dia akan bagi jadual, ikutlah kesusahan, you akan ikut kesusahan lah. Okay? I tahu bukan di kelas, cuma I nak remind again and again and again. Okay? Alright? So, okay. So, any questions so far?
Doktor,
Okay.
nak bukan tanya, nak sahkan, nak mengesahkan. Soalan yang nombor 2 tadi kan, kita satu kita nak cari dekat delta V, lagi satu dekat delta V, dekat delta D kan?
Tak. Nombor 2 Nombor 2 yang mana
Yang dia punya lukisan dia tu ada 15 kilo, dekat C ada 15 dengan 20.
Oh, I nak
Yang
C
nombor
saja,
2,
yang tu C saja.
yang C saja.
C, vertically.
Vertically. Oh, yang mula-mula tu B kan?
Yes.
Okay.
Ah.
Okay. Lagi satu doktor ada orang request.
Kenapa
Boleh
orang
tak kalau
request? Kenapa orang request? Bukan you yang request. Siapa orang tu? Dia tak boleh cakap sendiri?
sama-sama request doktor. Okay, untuk kelas kita boleh tak kita orang nak start pukul 10?
Tak, I want to ask everyone here if okay to do at 10 a.m. Sebenarnya I memang request. Bukan you request. I yang request. Before you do at 10
Sama
a.m.
request doktor.
Hah?
Kita sama-sama request lah kalau macam tu.
Ya, sebab I ada kelas 8.10, lepas tu I nak kena rehat. And then 10.11, and then I rehat sejam lagi 2.4. So I rasa baik I rehat 2 jam terus rather than I rehat sejam-sejam. Macam itulah. Tapi I want to check with all of you since everyone is here. So is it okay? Any objection with the time yang kita cepatkan kepada 10? Ini online boleh kita buat 10 nanti kalau face to face kena check dulu kelas tu available pukul 10 ke tak? Faham tak? Siapa yang tanya I tadi? Sarah.
Saya.
So kita boleh buat yang online ni, tapi kalau face to face I'm not sure. Kita kena identify bilik tu pukul 10 hingga pukul 11 dia free ke tak. Kalau dia tak free, kita kena cari alternatif lain. Faham?
Rasa majoriti okey doktor.
Rasa majoriti. Ya ke? Semua
Dah
okey?
bincang lah.
Okay. Oh, you dah
Okey,
bincang. Okay,
Ah.
good. Okay. So, kalau dah bincang okey lah, kita akan start next week pukul 10. Okay, next week pukul 10. Selalunya I akan buat kurang sikit lah sebab I takut you ada kelas. I ada kelas pagi tu 8.10. So, nanti I mungkin terlajak sikit, you dah masuk dah. So, kita akan start 10 suku lah selalunya. Okay? Boleh?
Boleh doktor.
Alright. So, kita akan buat 10. Tapi ni kita stay on the online only ya. Online, kita start dengan online dulu. Kalau kelas nanti kita check dulu. Okay, kalau kelas tu available dan someone akan boleh find kalau lah waktu yang kelas kosong and then we move to 10 a.m. on Monday and Tuesday. Okay? Boleh? Sebab jadual waktu ni kalau seingat I yang buatkan jadual I, dia kata dia tak boleh. I memang request dekat dia pukul 10 sampai pukul 12 tapi dia kata tak boleh. Sebab dia kata selepas 2 jam kena rehat. Macam itulah. Tapi I kata okey je kalau waktu tak puasa okey je. Waktu puasa ni pun sebab tak berjalan-jalan kan. So okey lah lagi. Okay? Alright, I nak panggil nama. Abdul Qayyum.
Saya doktor.
Alia, tadi ada Alia Najiha adalah, I rasa semua ada ni kat 26. Okay. So, cuma cakap je. Amir Karimi.
Ya doktor.
Arif. Where is Arif? Tak tahu. Arif Ali. Where is your mic? Tak dengar. Ari Arman.
Saya doktor.
You yang bercakap tadi kan. Atira. Auni Arifah.
Ada madam.
Okey, Dayang. Tadi saya lupa. Wan Nur Sarah tadi ada. Sebab dia yang bercakap bagi pihak. Kia Satina.
Ada doktor.
Okey, Mio ada lagi tak?
Ada doktor.
Haikal.
Saya doktor.
Hakim.
Ada doktor.
Zik.
Ada doktor.
Tak ada.
Ada.
Fatwa.
Ada madam.
Afika.
Ada.
Okay, Afrina, where are you? Ada kita? Okay, lepas ni tulis, respond ke I walaupun mic you rosak ke apa, okay? You not responding me. Okay. Maisara,
Ada doktor.
Nabila,
Saya.
Ashikin,
Saya doktor.
Ronaldo,
Tak ada. Ada
Shirley,
doktor.
Ada doktor.
Najiha,
Ada doktor.
Amira, Nur Amira, Wan Nur Amira. Where are you, Wan Nur Amira?
Doktor.
Yasmin.
Ada doktor.
Alright, okay. So see you next week on Monday at 10:15 a.m. Sorry, 10:50 a.m. Okay, so pastikan siap 3 soalan ni. And then next week at least kita akan discuss soalan tu dan I panggil seorang-seorang. I akan terangkan balik soalan example 1 and 2 tersebut. And then soalan ketiga nanti kita bincang bersama-sama and I ask the question, ask some of you, one of you or semualah I akan tanya. Okay, yang dah bertanya tu tak adalah. Jangan fikir kalau hari ini I tanya, dia tak mungkin akan ditanya minggu depan. Okay? Okay, alright. Okay, Assalamualaikum.
Waalaikumsalam. Thank you, Doktor.
Waalaikumsalam.
Doktor.
Doktor.
Alright, thank you.